All right, so this is lesson 21 plus. This is moving from one variable to two variable inequalities. So this first part, we're going to describe the regions of the planes. So what would you say about graph A?
Positive.
The shaded region is positive what values?
Positive what?
Positive y values. Yeah. Positive y values. X values are both negative and positive on this one, right? Yeah. So just the y values are positive. What about graph B?
Both negative x values. Negative x values.
So all of the points have a negative x value. Negative. How did I word that? I did say y values. Negative x values. Or we could say x coordinates. Okay. What would we say for graph C?
They both have positive x and y values.
Okay, so positive x and y coordinates. Okay, what about D? What does that one have?
They both have negative x and y values.
Ooh, they're both negative? You sure about that?
One's positive and one's negative.
One's positive and one's negative. Which one's positive?
The X.
Okay, so positive x coordinate and negative y coordinate. All right, when you're done with that, turn to the next page. All right, so more or less. We're going to write at least 3 values for x that make the inequality true. Any number. We need a number that makes this inequality true. So x equals what?
Negative 1.
Is negative 1 less than negative 2?
Negative 3.
It's more.
Negative 3, negative 4, negative 5.
Negative 4.
Okay, negative 3, negative 4, negative 5. Okay, what about b? What values of x make this true?
3 and above.
Okay. So 3, 3, 4, 5, that's fine. So anything that makes that true, so we want it to be greater than 4 on the left side. So 2 would make it equal, so anything greater than 2. All right, what about C?
4.
Let's solve it, because I don't quite remember. So if we add 1 to both sides. All right, so that's 8. If we divide by 2, x is less than or equal to 4. So what could our values of x be?
4.
So 4. What else?
3.
3. We're going down this time. Why are we going down?
Because it's less than or equal to.
Because it's less than or equal to
2.
2. All right. Now we're going to graph the solution to each inequality on a number line. So graph A, we have, so the x is less than negative 2. Is my circle going to be solid or hollow?
Hollow. It's going to be hollow.
Hollow. Where's it going to go on my graph?
To the left.
Negative 2.
Negative 2. Is my line going to go to the right or to the left?
I can't
The left.
see. Oh, there we go.
There you go. To the left. Okay. What about graph B? We have
Hollow starts on 3 and ends on 3.
it's hollow and it starts where?
On 3. No, wait.
4.
Mm-mm.
Isn't A hollow though?
Oh, it is hollow. Sorry. I gave you a solid. Thank you.
Oh, man.
It is hollow. That was my bad.
Hollow.
Okay, what?
Forgot what does hollow mean?
Hollow means that it's not equal to that number. So it needs to be greater than or less than, in this case. It needs to be less than -2. For B, if we went through and solved this equation like we did with the other one, if we subtracted 2 from both sides, we'd have x is greater than what? What's 4 minus 2?
2.
So my circle goes where?
2.
On 2, and it's going to be
Oh, I see.
hollow. Which direction does it go to? To the right or to the left?
To the right.
To the right. Okay. What about C? Where do we start there?
2.
Mm-mm.
4.
4. Solid or hollow?
Solid. Or filled. Solid.
Solid or closed or open, however you want to say it. Open would be the hollow one. Okay, so it is a solid or closed circle. Does it go to the right or to the left? Goes to the left. Why does it go to the left? Because it's less than. Because our solutions were on the left side. The 2 is on the left side. Okay. Using the inequality x is less than -2, write 3 coordinate pairs for which the x coordinate makes the inequality true. So, just looking at x coordinates, somebody pick a value.
2.
Is that less than -2?
-4.
-4. So if we look at -4 for an x value, somebody pick a random number for y. Doesn't matter what it is.
12.
It does need to be on this graph though.
Oh, okay. 8.
8. Okay, so if we go over here and put -4, 8. Okay, somebody pick another one because we need 3 pairs. What's another value that makes the inequality true for x?
-6, 4.
-6, 4. Okay, and one more.
-8, 0.
Yep, that works too. -8, 0. Yep.
Okay.
We could also have -8, -8. It can be anywhere on this side. Okay? So, let's see here. What do you notice about the points that we found that are solutions to the inequality?
We go
Keep going.
Over to the left 2 and down 4.
I mean, you could say that, but what if I put a point right here? Does that still satisfy the
Yeah.
the inequality?
Mhm.
Yes. What about here?
Yeah.
What about here?
The x value has to be less than -2.
Just the x value has to be less than -2, so I could pick any point over here. Okay? So here's how we're going to show that whenever we are graphing an inequality. So we could say this is a linear inequality. You know, whenever you graph a line and you have x equals a number, what do you do?
Go over 3.
So if I had x equals 0, what would I do? If I were graphing it as a line. Does anybody remember? Or what if I had y equals 4? What did we do with that?
Like when we graphed it,
Uh-huh.
like didn't we go up 4 and then?
So that's if you have a slope, but what if we don't have a slope? If I had,
Under it, the y goes in it.
if I just have y equals 4, what did we do to graph that line? Does anybody remember? It has been a while.
Can I put a 1 under it?
Mm-mm. That's whenever we just drew a horizontal line through the 4 on the y-axis. Do you remember that?
Oh, yeah.
Okay, so if we have x is equal to, sorry, I'm going to go back, x equals -2. What am I going to do with that?
Draw a line over the -2.
Draw a line over the -2. Okay. But it's not equal to -2, right? In our case, we're looking at x is less than -2. So does it equal where that line is?
No.
No, why not?
It can't be on 2 because it has to be less than
It has to be less than 2. So whenever we're graphing like this, I'm going to go ahead and show you this on this page. You're going to do a dashed line. So I'm going to erase this. All you have to do is go through and make dashes. And all of your solutions are going to be, ooh, that's not what I wanted. Everything,
I would just like the ones that were on the first page.
everything on this side of the line. Okay, so you're going to have a dashed line. Your solutions are everything on the left side of that dashed line. So that's kind of what we're going to be doing for this right now. Okay, and when you're ready, let's go to the next page. Okay, above or below the line. Now, how do we graph this? We have y equals 3x minus 4. Where do we start? We start where? What format is this in? Brayden? We started -4. Where do we go from the -4? Yep.
Go up 3 over 1.
Up 3 over 1. One thing I want to note before you make your next dot is that this graph is by 2s. Does everybody see that? So you need to go 1, 2, 3, and to the right 1. So your first point will be in the middle right here. Okay? And then go 1, 2, 3, 1. Or you could go 2, 4, 6, 2. So your line is going to look a little bit different because you're not going to be going up 1, 2, 3, 1 because that's going to give you a different slope.
So we're going over 2.
So if you go up 6 to the right 2, you will have the same slope so that you end up on the corners. You can do that. Or you can go up 3 by going in here and going 1, 2, 3, right 1. You just have to pay attention because this is going by 2s down. So we want our slope to be 3. If we went up 3 and to the right 1, that would be a slope of 6, not 3. Does that make sense? It has to do with the fact that the scales are different. Okay? So, let's see here. I'm going to finish doing this, and I'm just going to go up 1, 2, 3, and then go over 2 because I like for my points to be on the corners. I just think it's more, I don't know. It's my thing. I like it to be on the corners. It's easier to see and do. Okay, then connect your points. And do your best to make it straight. It's okay if it's not. All right. Is the point 4, 8 on the line? Yes or no? Yes. How do you know it's on the graph? Or explain using your graphs. How do you know it's on the graph? So I go over here to 4 and then go up to 8. How do I know that that point is on the line? This one's pretty simple. It's just because it goes through the line. So you know that it's on the graph because the line goes through the point 4, 8. Explain how you know using the equation. What can we do? Yeah, we just plug the points in using substitution, right? So if I do substitute. So if we had y equals 3x minus 4, and we had 4, 8. If we plug that in, we get 8 equals 3 times 4 minus 4. What is 3 times 4? What is 12 minus 4?
8.
Does 8 equal 8?
Yeah.
Yep. So we know it's a solution.
Can I use a restroom?
All right, so you should go to the next page if you are ready. And we may do some flipping back and forth a little bit. So, actually, what I'm going to do is I'm going to take a screenshot of this and pull this over to the other side so that we can see the graph and these questions. Okay. Add. Okay, so we have 3-point values, so we have x values. We need to find, we have x values for the first 2 points, and we have a y value for the last point. So we need to find values for A, B, and C so that the points are on the line. So for A, we need to look at 5. Here, I'm going to do this in, let's do this green here. So we're going to do A in green. We're going to go over to the 5 and then go up to here. What is the value for A that is on the line? So we have our x value, which is 5. If I look up on my graph from 5 right here, what is my y value? Right there.
Like where they cross?
Mm-hmm.
Is it 10? Like 12?
So I've got about 11 on mine. It should be a little bit below the 12 point. But mine over here actually looks like it's going through the 12. So I will take 12 for this one. So 10, 12, somewhere in there. Because, of course, my line is not straight because I freehanded it. So if this was like perfect, it would probably be about 11. Okay, now let's look at B. Let's do B in pink. So we're looking at -7 on our graph to find our B. So if we go over to -7, and we're going to go down to where the line is, approximately, what is that point?
25.
Okay, it's -25. Make sure you get your negatives in there. So that's good. So B is -25. And then lastly, we have C. Let's see here. Somebody pick a color.
Green.
I already used green.
Brown. Red.
Purple. That was also said. Okay, so now we have C. With C, we are given the Y value, so we're looking for the X value. So for my Y value, I'm going to go up to 20 and across. What is the point? What is the X value here? 8. Okay. Now we're still doing A, B, and C. So I'm going to still do these in, we have green, blue, or sorry, not blue, pink, and purple. So we're going to pick points that are above the line. So for A, we're going to go to 5 again. So we're going to go back to this point right here. Somebody pick a point that is above the line for a Y value. Any number. 16. 16 is above the above the line, right? Now we're going to do the same thing for B. So we're at -7. Somebody pick a value that's above. What?
-6.
Yes. -6 would be above because -6 would be up here, right?
Yeah.
Okay. So -6 works. What about C? If we're at 20 on the y-axis, what's a value for X that is above the line?
20. Oh, wait. 12.
12? If I go to 12, 20, is that above the line?
Oh. 24.
What?
24.
No. Our Y value is already 20. We're looking for our X value down here. So we need our X value to be 12, 20 is right here. Is that above the line? 420.
Oh, I see.
420 is above the line. Now we're going to write values that are below the line for A, B, and C. So again, same colors. Okay, so for A, we're going to 5 again. So somebody pick a value that is below the line for the Y coordinate. 80? Did you say 8? Yes, 8 is below. Right there. Okay, what about B? So we're going to -7. We need a point that's below the line for our Y coordinate. -20 is up here. We're down here. We have -7. We need below -25. So we have to have -7 as our X coordinate. We need a Y coordinate that will be down here.
26.
-26 works. Yes. Okay. Ooh. Drop my pen there. Okay, C. Now we have our y coordinate is 20. So again, we're back up here. We need a coordinate that is below the line. So we actually already had one of those earlier. This one right here. What was the coordinate for that?
20, 12.
12, 20. So for C, we can put 12. Okay, so this is just the introduction to this. And tomorrow we will go into more depth on this and get more into graphing. You guys don't have homework for today. So I would use this time to work on making up any work that you need to get done